Today we're going to talk about equations and their solutions. An equation is a mathematical sentence showing two expressions are equal. An equation contains an equal sign. Some equations contain variables, and when you're given the variable, it's a letter for a value we don't know. So that's why we need to find a solution. We're going to substitute it into the variable to see if it makes the sentence true. When you replace a variable with the value that results in a true sentence, then you have solved the equation. The value for the variable is the solution of the variable. And like in first grade, when you were given the box, and you said 2 plus a number equals 5. And in sixth grade, we learned that if we put a variable in for it, same thing as the box that you learned in first grade. Well, this is what you're looking for. You're looking for the solution that makes this true. So 2 plus 3 would equal 5. This solution makes this true. What's 2 plus 3? 5. And does 5 equal 5? Yes, so 3 would be the solution. So let's look at example 1. Example 1, you have 21 minus a equals 15. Well, you have to try to figure out what number you can put in for a to make this true, this sentence true. So when you are given values, I would just write all of them in. I would substitute the 4 in for the a, and then I would write your mathematical problem. I don't like to add or subtract horizontally. I like for them to be vertically, so I always just reset my mathematical problems straight on top of each other. And now, instead of saying 21 minus a, I have substituted the choices that I was given in for a. So 21 minus 4, if I regroup, take away 1, 10 from the 2, leaving me with 1, bring it over. 11 minus 4 is going to give me 7, and then bring that down. Well, this, if a equaled 4, then this side would equal 17. 17 does not equal 15. That is not equivalent, so it's not a solution. So I'm going to cross off my 4. 21 minus 5 is going to give me 16. If I substitute 5 in, 21 minus 5 is going to give me 16. 16 is not equivalent to 15. So I'm going to go to my next. 21 minus 6. That is going to give me 15. So when I substitute 6 in for a, 21 minus 6 is going to give me 15. And 15 is equivalent to 15. So I have found my solution. My solution is 6. That is the value of a. That is what makes the sentence true. Let's jump down to example 2. Select all the variables that make the equation true and show your work. So here's your equation. They want to know if 2/10 is the solution, if 6/10 is the solution, or if 3/5 is the solution. Well, we are going to just set the problem up and try to figure that out. I see that this has a denominator of 10 and this has a denominator of 5. So I'm going to have to find an equivalent fraction so I can add them together. Because remember, with fractions, you can't add them unless they have the same denominator. And I am going to have to switch. I'm going to have to change one of my fractions, my 1/5. So I'm going to write my fractions vertically so I have room to write my new fraction. I don't have to do anything to my 2/10, and I went ahead and wrote it because I know 5 goes into 10. I know they both have the common denominator of 10, so what did I have to do to the 5 to get to 10? I had to multiply it by 2. Whatever I do my denominator, I do my numerator. 1 times 2 is going to give me 2. And it said I was adding these. So when I add fractions, I keep the denominator the same and I only add the numerator. 2 plus 2 is going to give me 4. Is 4/10 equivalent to 8/10? No, it is not. So that is not a solution. I am going to try 6/10. Put in my 6/10. I know there's my 6/10. I'll substitute in for that, and I'm adding 1/5. And I want to see if it equals 8/10. Again, they do not have the same denominator, so I have to rewrite them with the same denominator. And they both go into 10. Since it's the same denominator, nothing will change on my first. But again, I have to multiply both sides by 2 and then add them together. I know I have 10 as my denominator. 6 plus 2 is going to equal 8. So when I put in 6/10 over here, 6/10 plus 1/5 is going to give me 8/10. And 8/10 is equivalent to 8/10. So I know that this is a solution. Now let's go to my third box. It's saying that 3/5 plus 1/5 should equal 8/10. Well, since it's asking me in tenths, I want to go ahead and turn these fractions into the same denominator as my answer. And both of these go into 10 2 times. 3 times 2 is going to give me 6, and 1 times 2 is going to give me 2, and I add my numerators together, and that will give me 8/10, and 8/10 is equivalent to 8/10. So 3/5 is also a solution in this problem. All right, let's jump down to number 3. Okay, so now this one is saying 2 times A plus 5.5 is equivalent to 17.3. Now, remember orders of operation. I have to do my multiplication first and then my addition. All I'm going to do in every single one is I am going to substitute. Since 2 is a smaller, has less digits than the A, I'm going to just put, oh, that's not a decimal, that's a multiplication sign. So I'm going to say 4.6 times 2, which is going to give me 12, and then I carry my 1, of course, and then 8. 2 times 4 is 8, and then I add my 1. It's going to give me 9, and then I keep I add 1 place behind my decimal, so I'm going to keep it the same way. Now I would add my 5.5. I multiplied, when I substitute 4.6 in for A, I multiplied 4.6 times 2, which gave me 9.2. Now I'm going to add the 5.5, and that is going to give me 14 sevens. I am looking for it to equal 17.3. So I know that is not going to work. I'm going to substitute my next given amount in for A. I'm going to use a little times this time. Times 2, which is going to give me 18, and 10, 11. Keep my decimal 1 place behind, 1 digit behind, and then I'm going to add my 5.5. 8 plus 5 is going to give me 13. Bring up my 1, 5, 6, 7, and then bring down my 1. So I see that 5.9 is a solution. And now let's just check my 6.3. Even though I know that I can only multiply 5.9 with 2, this will be the only solution I have. I just want to make sure that I didn't do my math wrong on this. So the reason I had 2 answers here is because fractions, they can be written equivalent to each other, but they could be different numbers. I can only have one 5.9 unless I write it as, a fraction, 5 wholes and 9/10, something like that. But all of these they don't have any fractions. There's no mixed numbers here. So I know I can only have one solution. But again, I want to check and make sure that I didn't mess up on my math to begin with. So I have 6 and then 12. Keep my little decimal. And then I'm adding 5.5. Add them together. 7, 8, 18.1 is not 17.3. So yes, I did my math right. My solution is 5.9. Example 4. Select all the equations that have x that equals 6 as your solution. So automatically, I'm just going to substitute the 6 in for each of my equations, for my variable in each equation. And then I'm going to solve it. So 3 times 6 is 18. 18 divided by 2 is going to give me 9. And what am I looking for? I'm looking for 9. So I know A is 1. Go to my next one. That's 4 times 6 minus 4. And I want it to equal 21. Remember, I have to do orders of operation, so multiplication first and then subtraction. 4 times 6, 24, minus 4 is going to give me 20. And I needed it to be 21. So 6 is not the solution for this. Go down to C. 2 times 6 plus 10, following my orders of operation. 2 times 6 is 12, plus 10 is going to equal 22. And what was I looking for? I was looking for 22. So that is definitely a solution. And then here I have 90 divided by 6. And when I have 90 divided by 6, which I could have written, I guess, like this as well, I have, 6, 3 brings, so 15. And does it equal 15? Yes. So here I had 3 equations that 6 was the solution. All right, remember, always check all of your solutions. Oh, well, let's try with your turn. I want you to pause the video and solve these. You are not allowed to use a calculator. These are your choices in parentheses. And then once you have all your answers, check with me to see if you're correct. Okay, so I'm assuming that you pause the video. First thing I want to do is I want to substitute each value into this equation and see if it's true. So use 5 first. 25 minus 5 is going to give me 20. And what am I looking for? I'm looking for the 20. Since they are all whole numbers, I know that I'm only going to get one solution, but I want to make sure that I check just in case I did my math wrong on one of them. So if I have 25 and I substitute the 6 in, that's going to give me 19, which is not 20. And then if I do 25 minus 7, that is going to give me 18, and that is not a solution. So 5 is my solution. Ugh. Now, let's go to number 2. And remember, an equation, I can write it 5 equals 2 plus 3, and that is still correct. It's still equivalent to each other. So just because you have one term on the left side, that does not make it any less true. If you're not comfortable with it this way, you can rewrite it and switch the terms on the other side of the equal sign. It's not a big deal. So now you would have to substitute in your 1/2 and your 1/4 and your 1/3 in with J to see which one is true. Well, with the 1/2, 1.5, and you subtract out a half, that's kind of easy to compute, because if you have a half and you take away a half, you're going to be left with 1, and 1 does not equal 3/4. So I know that that is not a choice. My next one, I would do 1.25 minus a half. What I would do is convert this into an improper fraction, so 4 5/4. And then with this one, you need to have the same denominator. So 2 goes into 4. I'm just going to multiply both of these by 2, leaves me with 2/4, and I'm subtracting them. So 5 minus 2 is going to give me 3. 3/4. What am I looking for? I'm looking for 3/4. So I want to go ahead and know that that is a solution. And then my other one, J, so 1 3/4 minus 1/2. I know that this could turn into 2/4, and this right here is, the 3 is more than the 2, so I'm not going to turn this into an improper fraction. I'm just going to leave it the way it is. I have 1 whole, and then 3 minus 2 is going to give me 1/4, and 1 1/4 is not equivalent to 3/4. So my only solution here would have been the 1 1/4. The reason I turned this into an improper fraction is because if I had just carried the 1 and the 1/4 over, then I would have had a 1, and I'm trying to take away a 2, and that would not work. So I need my numerator to be greater than the numerator I'm taking away. And in this case, my numerator was greater than my numerator that I was taking away, so I didn't change it to an improper fraction. Okay, number 3. I see the expression 2 times a plus 7.2, and I know that this, to be a true statement, to be balanced with 19.8, I have to substitute these into this and see which one's true. So since there's more digits in here, I'm going to put that on top when I multiply the 2. 2 times 2 is 4. 2 times 4 is 8. And then since there's only 1 digit behind my decimal, I'm going to just keep 1 digit. And then I'm going to add the 7.2. Line my decimals up, bring them down. 4 plus 2 is 6. 8 plus 7 is 15. That equals 15.6. I need it to equal 19.8. So 4.2 is not going to work. I'm going to do 6.3 times 2. It's going to give me 12.6. Add my 7.2. It's going to be 19.8. And what am I looking for? I am looking for 19.8. So when I have the solution 6.3 in for A, then that is balanced. But make sure I don't do my math wrong. I'm going to substitute all of my choices in to make sure. Add my 7.2, and that is going to give me 17.8, and that is not what I'm looking for. So 6.3 is my solution. Jump down to number 4. Select all the equations that have x equals 12 as a solution. And here, I would just substitute and just start it. So 6 times 12 over 9, and I need that to equal 9. So I have 6 times 12, which is going to equal 72, and then I divide that by 9, and I am going to get 8. So this side would equal 8, and 8 is not equivalent to 9, so that would not be a solution. I'm going to go to B. 72 minus 12. And that's going to give me 60. And what do I need it to equal? 60. So B, yes, it does have a solution of 12. Let's jump down to C. This says 5 plus 3 times 12 equals 96. Well, remember order of operation would be multiplication first. So this would be 36. And then if you add the 5, that is going to equal 41. And does 41 equal 96? No, not a solution. Let's go down to D. 6 plus 12 is going to equal 72. And what am I looking for? 72. So I have 2 solutions on that one. Okay, and that is our lesson. You will go to Canvas and you will solve, you will look for the solutions. When you do Canvas, instead of having a parenthesis with your choices, it will be down in your choices. So you'll have your question and then you'll have to look at the choices and substitute them in to see if they work.